Hey, hello. Okay. Hopefully we're live now on Twitch. Whew. Sorry, this is a very impromptu stream that I'm probably not going to be lasting very long doing this, but I just thought I'd say hello, guys, because I've not done this in a while. I've usually not had the time to do it. So yeah, because I'm now here, I'm going to have to do the obvious things, which is tell people that I am actually streaming, because that usually helps. So let me just get onto the interwebs and do that. That's one on one of the interwebs, obviously. Social media is obviously, and that's what I'm referring to here. And go on. Right, hello, hello. Look, Twitch notify is, I cannot be bothered to do all that kind of stuff. Man, it's just too fancy for me. Right? So hello, right, what we're going to be doing today is some programming for the Odin compiler. Explaining what I've been trying to do for a little while and where I'm getting stuck as well. There's been some roadblocks. Unless someone else can actually help me out with these problems, please do. So yes, hello everybody, how you doing? This is all should be hunky-dory. So there we go. Let's do, oops. All right, let's do that. Good. Life is treating me well actually at the moment. Thank you very much for asking. Just scratch the peach fuzz that I've got, which I just shaved down. Right, so let's go to not just seeing my face, because you guys don't want to just see my face now, do you? You want to see code, actual code. Unless you really want to see my face. I don't know if you do or not, but probably the code is what you want to see, not just me. Hello everybody, how you doing? Right, how you doing? Right, so today is kind of more me explaining I'm doing some random stuff with the compiler, but specifically I've been trying to optimize the compiler for non-optimized builds to be faster, right? And it's really hard to optimize at the moment. So unfortunately, it looks like I'm going to have to be doing one thing, which I didn't really want to be doing in the first place, just because of LLVM. This is all it is really at the end of the day. Incremental builds. Yeah, wasn't really planning on that actually. So before I go on to the kind of thing, I'll just talk to the camera here. But yeah, incremental builds is one idea that I'm probably going to have to do. My colleagues have been asking it for ages. And I've been getting annoyed at them, to be honest with you. The reason why is they keep saying, well, we want incremental builds. I'm like, no. You want fast compile times. And you keep telling me a solution to get them. That doesn't mean that's what you want. But they keep repeating this, and it still kind of annoys me. Because it's like, well, no. So I've been looking at which bits are slow bits. Obviously, LLVM is taking up about a third of the compiler now, by the way, which is quite impressive. It used to be around about 90%, and now we've clearly crammed that down as much as I can, and then trying to make everything else has to be optimized. But yeah, if you're getting it down to a third, maybe 40%, I think that's okay, but it's still not great. Like if I could get that even further down, because if you look, I'll show you some of these stats I've been doing in Superluminal and showing you how that works. It should be better, if that makes any sense. But for the most part, it's a question of where to go from now. I'm going to explain some of the problems I've actually hit trying to even work on incremental builds. Because it's not as easy as you think it is. If you even think it's easy in the first place. By the way, incremental builds is actually extremely difficult to do correctly. And I'm trying to make sure I've got the infrastructure there first before I even do the obvious things, such as like, finding out if this file or this package has been updated. Right, has been modified in some way. That's the obvious things. I'm like, no. I've got to work on the other stuff first, which is the infrastructure to make sure that can even be, any of that would work, right? So hopefully that makes sense. I'm going to, first off, going to show the code here. Show the screen here. And this is me at the moment. And this is before I did a stream. It's going to be slow because it's on a stream. So I'm expecting probably, yeah, that's about right. Yeah, 1750 milliseconds. This is to build LiquidGen at work, by the way. DjangoFX is LiquidGen. And this is with an unoptimized version of the compiler, building an unoptimized build of LiquidGen, because I want to be able to keep rebuilding, optimizing it. Now, if I did an optimized build, this could go down quite far, actually. It'd be quite nice. But if you actually, if any of you guys can see this, I probably need to make this a little bit bigger for the screen. This is the full like timings for the different sections within the compiler, showing you kind of different things. And this is just a general overview. So interestingly, this number here, 2.38% of the time is spent in parsing files. According to the file, because again, when you're on stream, things go slower anyway. I'm normally not seeing 41 milliseconds. I'm usually seeing about 31. But again, streaming takes a lot of bit of the compute of the CPU, as well as some of the, sometimes the memory as well, so it makes things a bit slower. But you can see all the different things. Like, unfortunately, a big section of this is this. Now, look, there's a table of numbers. Some people are not good. It's not like reading the Wealth of Nations, where you've got a table of corn prices that Adam Smith's done. People like visual graphs, but again, they weren't invented back in 1776 when that set of books was written. So nowadays, I like using something superluminal. So this was one I did earlier, obviously. This is what comes out of the oven previously. And it's looking at what sections of the compiler this is. Now, if some people were following on Twitter earlier, I did a annotated diagram of what each section is and what it is for. So let me just get that diagram up now for you. Here we go. Right, here's the diagram that's been annotated. I'll hide that so it makes it easier to see. But this is effectively the same. You can see it's very similar because it's from a different section, obviously. Of what the compiler is. Now, this is again in that span of about, what, 1700, 1800 milliseconds for a full compile time. Now, that's on my machine. My machine's pretty fast, but some of my colleagues, it's 2 to 3 times slower for there because their CPUs aren't as fast. Now, it's quite interesting to look at it. Parsing, I've done virtually nothing other than multi-thread it. I've not even tried to optimize it because guess what? Parsing is so dumb. There's these little spikes here and these things here. These are like the trivial like optimization things like collecting globals and other collection of stuff. Then unfortunately, you can see there's a bunch of red here, which means these threads aren't being utilized. And there's a big green thing at the start. This is the main thread. Unfortunately, this is the single threaded part of the front end, which is checking the globals. There's a big comment in the code base, and I'm not making this up. Let's go to checker. Here we go. Global, check all global entities. And I've had this comment here for a while. It says, note to Bill, this must be single threaded. Don't bother trying. Because guess what? Unfortunately, the design of Odin has a trade-off. It's not a flaw, actually, because unfortunately it was a heuristic when I was designing things. And how do I put this? The design of Odin is I had a heuristic, or not a heuristic, but more of a hypothesis that most of the time in a front end is going to be spent type checking the bodies of procedures. If that makes a bit of sense when I'm clarifying that. And turns out that's completely true, because if you look at this section, I've just set it to be 16 cores. Actually, this is the front end section, right? From where that pink thing is. If you actually made that single threaded, most of the time is spent in the procedure body. So my heuristics are completely correct. So when I designed the semantics of Odin, I made it to be very hierarchical. So you'd have each level of scope, as long as that, like we say, the first scope, the parent scope is done, then all of its children's scopes can be then done out of order, and then there its parent scopes have order, right? It's a very hierarchical approach. The problem is when you've got a lot in the global, like the global scopes, plural. So these are all like the type declarations, the procedure signatures themselves, not the bodies, but the signatures. You've got a lot of code in there that becomes single threaded. Now, there are places we could probably still multi-thread aspects of it, but I don't think it would make massive speed ups. So the only way to real speed this up is actually to do proper optimizations, try and improve things and profile that actual section of the code. The second one here is the check procedure bodies. Like, look, that is so trivially multi-threadable. It's nice and green here. Now you see there's a bit of red here. Now this is actually just due to doing the loading of like that, you know, the load directives, like load a file into memory. I think of actually loading directory, whole directory into memory. So this is why it's a bit blocked here. It's waiting on everything else to be done. Now this little, again, some bits you notice that in the front end, we're very clever with our divide and conquer method for multi-threading. So this dash bit here is checking all of the scope usages, making sure they're all correct. They can be done out of order because we're only checking. We're not reading. We're just reading. We're not writing. There's another unfortunate thing here, which is single threaded, which is checking the global initialization order. Now you could hypothetically multi-thread this, but because it's a graph theory topological sort with actually generating the graph to then do topological sort to then do the stuff on it, you don't want to multi-thread that either. It's not a big section, if you can tell. It's about 5% of the entire compile time if you look at that thing. About right, yeah, 5, maybe less. It's annoying. That's okay. Looking at other things, I have to tilt my head when I look at this, obviously, is then the dependency tree update. So when we have different procedures and all the types, we want to make sure we update the things that, hey, if this depends on this and this and this, we set the dependency tree up or graph or whatever to what we need it to be. That can be easily multi-threadable, but you can see it's not utilizing many threads. So if we actually look in the, sorry, let's get that back up and get this here. We can actually see why this has got a lot of thread contention in it. And unfortunately, there's no way of solving this, to put it bluntly. Yeah, here we go. Oh, I need to rerun it because, yes. Sorry, I just have to wait. Come on. Come on. Wonderful. Right. So this is the one that's got a lot of thread contention in it, right? So we go into here section, we click this one bit but randomly, and I can already guess what it is going to be. It's this absolutely stupid mechanism I've had to write to do the dependency child thing. Look, right? So when we add dependencies from a child to a parent, notice this is going to be a tree kind of diagram. We've got to use two different sets, two different sets, which is in total, I think, how many mutics? It's 4 of them, obviously, right? Because we're going to have to read from the current one, but then we're going to write to the parent scope by adding them all to its dependencies. So if you have a procedure that necessarily got another procedure inside of it, obviously, its dependencies is going to be dependent on what its childs are. If it's like, if whatever the child, whatever, it's a lovely little thing. And we also do a separate one here for all the type info dependencies as well. We want to find the minimum dependency stuff for the type information. So this is why this is dependency hell. Like there's loads of thread contention here, but unfortunately, if you literally look at how this implements, there's not really any better way of dealing with it. So it's kind of a, oh well, suck it up. But if you look in the grand scheme of things, because this bit here isn't actually, is it the same thing? Yeah, this is the another dependency tree thing, but it's just going through and it's still loads of thread contention, right? So this entire section here, according to this profiler, is about 56 milliseconds. Now it's going to be slow in the profiler because it's profiling, but in the grand scheme of things, it's nothing. So I don't need to worry about this thing. But there's these big sections here, like this here. This, as I said, is calculating the global initialization order. Now there's some other things in here, but again, they're like 11 and 10 milliseconds. Again, those things do add up a lot. But this global initialization order code, if we can actually see here, I don't know if you can actually read that code or not. I actually never find this useful, so I don't know why I don't ever have it just shut up. There we go, much better. It is just single-threaded code. There's not really any way to multi-thread this. It's graph crap. And it's still not even technically correct for everything because we're still not consistent with the rules. We need to write down the rules. They're hard. I know I may be blocking some of the code, but yeah, I'm trying to just show the general gist of this diagram is all I'm worried about rather than the actual code. But yeah, so this is kind of thing. So from about, whereabouts is the front end? The front end is here. All right. There, up to there is the front end. Now, annoyingly, of the front end, I'd say a third of it is taken up by, at least on my 60, I've got the 16 core machine, 32 hyperthreads. is taken up by a single, in fact, it's more than a third. I'd say half of it is taken up by single-threaded code. So guess what? We've hit Amdahl's law. For people who don't know what Amdahl's law is, I don't know why it's even got a name, but it does. It's the idea that as you increase the number of threads, your program tends to literally be dominated by the single-threaded bits of code. So to get like Milton open here rather than my Striga, because reasons, the equation is if you got the single-threaded code, which we call S, right? And then you got the things that's multi-threaded. Now I'm trying to think of a way of writing Amdahl's law, which is not dumb. Yeah, so the time for the single-threaded and then the time for the multi-threaded, let's do this. That's actually the same as equal, let's say, the total time, which is call it 1 for the time being, minus the single-threaded code, yeah? So that's the time for the multi-threaded code. So let's just make sure it's all in terms of this, yeah? So this should all equal to 1. So if you divide that by the number of like threads you've got, as this tends to infinity, like you've got many of in there, this becomes to dominate in your entire code. So another way of writing this is going to be 1 plus 1 over n. Actually, don't need to read. This is close enough. This is Amdahl's law, right? And your curves will look like something like this. So as you add more threads initially, you get a nice benefit, and then it plateaus out. Or a better way of drawing it would be like that, where it gets to a tendency where this is going to be TS. And this is the number of threads, the time. But as you can see, the one tends towards the other. So yeah, unfortunately, again, as someone says in the comments, some shit is not going to parallelize, and that is completely correct. But it is again, some flaws of Odin, like this big section here I'm not saying it's a flaw, it's a trade-off. Because I was trying to design Odin to be multi-threadable from the start when I was designing the semantics of Odin. It's just, unfortunately, you'll hit things that can't be multi-threaded. And this section, nope. And this section here is a nope. Now, certain other sections are possible. But this is where, in the diagram that we had previously, is this section called LLVM. And LLVM is a nightmare. You probably know by now that I don't like LLVM because it's not easy to multi-thread in the first place, and also all the bugs and everything like this. Now, in this section here, I've improved stuff before I took that image already. But if we start where LLVM starts from, which is here, and then ends about there-ish, I guess. It's a guess. No, a bit more further on, but let's go to there, which is the linker, right? Let's express what this bit of the code does here. Now, the first section here is a bunch of single-threaded code, and that's from, firstly, it says 21 milliseconds here, running on a stream obviously as well, is initializing all the generator code, and all of that is serialized as initializing all of the models. Now, one thing we could do right now, if you want to do on stream, and I just realized my camera's stopped working. Yep, that's insane. So I'll be right back just to restart the camera. I know what's gone wrong. It's just Windows. The trick is to unplug and replug the camera and see if that even works. And the answer is no. Well, you get to see the beautiful face of me. And there we go, we fixed. That was, there we go. Perfect, sorry. Yank the cable out and plug it back in. That's how it works. This is the technical skill that I possess. The prowess of it all. Sorry, I'm going back to this. Let's go back to the code, shall we? Explain this. So we can see here is, again, when I'm looking through the compiler, I'm doing this divide and conquer approach, which is not necessarily the best way of designing things for like multi-threading, but it's a really simple approach for when you want to do multi-threading in general, especially on a linear one-shot program. And the way I do it is like, okay, if this section here can be multi-threaded, we put it all into worker queues with a work stealing, and then carry on. And again, in many cases, there are multiple places where you can just do this really cheaply. Now, here is a great example of initializing the generator, and it's taken 21 milliseconds, again, while I'm streaming, so it's going to be a bit faster in practice, about 15, I'd say. But the reason why is it's initializing all of the code generation modules that we're going to be used for LLVM, and each of them is taking about, what, quarter to 1 millisecond each. So we could multi-thread all of them to reduce this time if we wanted. Again, it's probably something they're going to do on stream right now, just to show how to do it. So that's kind of that section. We can see when we're going in here, there's a bunch of red in here. So we go from this section here, and I'm going to, let's scale up. But again, in the grand scheme of things, it's nothing, but it all adds up. So if you can narrow things down where you need, it's great. Sorry, I've got hiccups now. The other problem we've got here is generating some LLVM code here, which is generate the procedure. A lot of it you can't do, but it's like LB type. This is from here. I can't even remember where that's being generated, but yeah, there's a lot of these things here. This is just generating the initialization code. So unfortunately, you can maybe speed this 20 milliseconds up, probably cut it down to 10, maybe smaller. But then this 44 milliseconds, you're not going to get much slower off anyway, so you're not a problem. But then after that, you can see we've got some more multi-thread examples. Like this section here, you think, oh, it's not very load balanced very well, and you'll be right. It's poorly load balanced. But here's the thing. Some of it's LLVM's fault and some of it's mine. So in this case, what we're doing here is creating the global procedures and types, plus generating I think in that thread here, we might also be generating, we're generating a lot of procedures actually. It's just not load balanced well. So the load balancing problem here, and this is actually not it's hard to deal with, right? So to explain how things work with them doing LLVM, to get things working faster in LLVM, you want to split up your code into multiple different like translation units, these different modules as it calls it. And unfortunately, it's hard to balance that correctly because how do you split your code into modules? Now, luckily, Odin has this natural unit called a package. And it turns out most of the time that's good enough as a load balance. But it isn't always, because some packages are bigger than others. And that's what she said, obviously, as well. But the thing is, there's where the problem is. When I've been doing the empirical stuff, a lot of it sometimes is stuck in some of the more common packages, like the runtime package, where like maybe you've got loads of occurrences of append or new or delete key and such. So you have this, like, okay, so what I've done there is okay, we can split the entire runtime package, which we know is going to be used a lot, and split them on a per file basis into multiple like sub modules. So instead of having a module per package, for the runtime package at least, we can have a module per file. Now that works a little bit, helps to distribute some of the load, at least in LLVM a little bit, but it's not enough. So the next step that I've done, which is also to explain one of the reasons why I'm hitting it is an annoyance because I'm trying to get incremental builds. That's the whole point of doing this. Is some modules, no, it's just for LLVM optimization. This is nothing about semantics of the language, by the way. It's more to do with, I'm trying to phrase this. It's more to do with like, okay, so let's go back to what I was explaining here. So we've got the submodules thing. So there's another thing what I've done is now I've split modules in two as well. So if you have a package, and within that package you have a lot of like parametric polymorphic procedures, well, we'll actually create a separate package in this a separate module, build translation unit, whatever you want to call it, specifically for the parametric polymorphic stuff, and then you've got the normal specific code and the generic code are separate. So that seems to help a little bit with load distribution as well. So it's always the question of where do you make this line. But the problem is some packages are just huge. Like the main package in your project will be huge, or some of the packages will be big as well. So it's this question of how do you minimize this or distribute the load distribution in a more consistent way. Because that's one thing is, again, is how do you divvy up this problem? Because if you can divvy it up correct, like if it was perfect, by the way, from this, all these big red bits here would all actually be gone. Because they'd all be load balanced correctly. There'd be lovely green chunks like we have in the front end, which are like the load distribution is kind of really good. That's why it's a lovely square chunk of green, that's squirrely chunk, but then the LLVM side isn't. So that's one aspect. Now, the other reason why, even if we got, how to this, you may think, but I'm trying to rephrase this. Yeah. So the way to phrase this is some people would go, but that's not necessarily a bad thing, right? Because if the load balancing is all over the place, isn't it just works out in the end, right? And I'll explain what I mean by this, right? So let's just go get Milton up again, just for this example. And let's say on average they all work out the same. So let's say you're a module, a translation unit in LLVM turns out to be about this width. Now, some of them are going to be smaller, some of them are going to be longer, right, in the amount of code that they've generated. But on average, they get to here. So this would be like the min, the max, and this is the mean, right? You'd think that is perfectly valid. It's going to be fine. And right. Sorry, the amount of dick jokes I'm trying not to say right now. This is really hard. Sorry, it's this time of night. But right. The problem here is that this is not how it works. LLVM has some pathological cases when it comes to passes. And some passes you actually require, even non-optimized ones, and just how it optimizes the code. And in general, not in the worst case, but like this is the average case of LLVM, that let's use n to mean effectively the number of lines in the module, like the size of the code, right? LLVM is going to do it's not going to be linear. It's going to be quadratic. So even if you've got the min, the mean, and the max here, what's going to happen is the maximums are going to, the bigger values are going to dominate more because they are literally quadratically bigger. So this is where you kind of get these problems. Again, it's a load balancing problem. So you want to kind of cut these down as much as you can. Now, this is why we also want to multi-thread and split into multiple modules rather than having one single translation unit. Now, someone was talking about earlier about like Unity build and such. Now, Unity builds are great when you're dealing with C because a lot of the time you're getting around some of the performance issues that you have that if you're trying to build multiple things at once. But if you have Unity builds, you actually get a lot of the performance benefits just by doing this. But Unity builds do suffer from the optimization path, especially now if it's used with Clang, specifically using C to do Unity builds, use Clang, you're going to have this n squared problem eventually. So even though Unity builds in the short term, or even the medium term, I should say, benefit you massively, they're not going to benefit you in the massive cases. All right? So how do we set this? So if we know that, let's say the complexity, let's call this K, is proportional to the code length of code squared, my camera's froze again. I am so sorry again. Yeah, let's turn the camera off for the time being and see if that helps, because it could be overheating. I have no idea. But in general, what we've got here is it would say it's K, the complexity of thing is called n squared. But let's say we split the amount of our code into m like modules, right? So we have the complexity now, say we've got reduced complexity of m over m. So we split them into m modules, right? Times it by m. But remember, each module is now going to be complexity squared. So if you look at this, you've got n squared over m squared times by m, which turns out to be, what you've just done here is, by splitting it into m modules, in the grand case, you've now reduced it, the actual complexity of a code, which is also the time, by a factor of m, which is really, really important to note, if that makes any sense. Someone's saying, what are they putting in the Irish water? I have no idea, because I'm not Irish. Some of the questions. Is there a reason why Clang struggles with C Unity builds projects? Yeah, it's because of this, because it's LLVM. It's non-linear. It's again, it's this quadratic thing. Yeah, that is still not correct with my camera. So you now get to see me, still frozen. Yeah, is that not gonna... No, that's not gonna do freeze. Great. Yeah, I don't have a Northern Irish accent, by the way. This is a very Midlands, East Midlands accent. So yeah, it's kind of interesting kind of what things are going to do to minimize it, because just do this basic algebra stuff, and that's why we're splitting things into multiple modules, translation units, what do you want to call them, for LLVM, right? Great, we're already doing this, still having a thing, and yet things just, this is not great. So this does raise the question of, okay, we want to minimize the space. So it's not the obvious thing is like, can we improve LLVM further? So we go back to Superluminal here to look how the code is. And unfortunately, we could still probably cut this off by at least a third. I've calculated from the red space and all the other calculations. We could get the LLVM code base down by literally an entire 33% at least, just by having a better load balancing. But again, how do you do it? Now, one argument you could say is, well, you could have per module per file in the thing. But the thing is, that doesn't work out in practice because some files are much bigger than others. So the question is, where do you split? And that is actually a really hard problem to ask. So that's the next question is, where do you make these transitions to have the better load balancing? Or at least, how can you make those transitions so at least you could give the diagnostics to the user so they could figure out what to do? But let's say that's just me trying to get the current system working faster. The next system, which is again what my colleagues have been moaning me about, which again, I don't like them telling me this, but I keep saying, like, no, you want faster compile times. It doesn't matter what it is, you just want faster compile times. And that would be incremental builds. Now, when I say incremental builds, I have to be very careful what I mean by this. Incremental builds does not mean the front end. It just means the back end. And you're going to be giving incremental builds to the back end, so you don't have to regenerate all this code. So you're still got, again, if the front end is 30% of the, or 40% of the, 30% of the compile time, that's always going to be that like amount, like the how many milliseconds that is. Let's say it's 500 milliseconds. You're not going to get rid of this because you may ask, why can't you do that in Odin? Well, because of the compilation model in Odin, it isn't the same. If that makes any sense. Now, let me try and get this camera working again, because otherwise people are looking like I'm looking at the blank screen still. Right. I think... it's just overheating, and that's actually the problem. So you're going to see full camera. The camera's not going to be working. And it should be back again. Hello, look at this. I'm on my knees. Oh, God, seriously, got the bad jokes. Right, and be very careful here. This is family friendly, even though I've been swearing. Right, so I'm back again on my screen. But yeah, this is kind of the problem when you're trying to do distribution. But when you're looking at the Odin code again, when we're doing incremental builds, it's just going to be on the back end, the LLVM side. So we want to minimize the amount of work we're doing here. So let's say how things are going to work. It doesn't... Oh, it's not the camera that's, by the way, it's not the camera that's overheating. It's the capture card that's overheating. And it's one of those Elgato like USB ones that you plug in. Yeah, it's clearly not the best. I think it's just overheating. But yeah, there you go. Now, this is kind of, again, this is our problem now of solving, I'm trying to rephrasing this, solving how to minimize compile things. So I was looking at incremental builds. Now, incremental builds is actually a very complicated problem, especially with Odin. Now, why is it complicated, you may ask? And half of it has to do with parapoly, which is parametric polymorphism or generics. And that may be confusing to people, but let's get the diagram up and explain what we mean and why it's going to be this more complex. So let's say we've got a package system. Let's call them very simple. We've got package A, we've got package B, package C, package D, and package E. Right, and I'm going to put some different colors here. So, right, say the arrow points to it means it's been imported by. Right, we're going to keep this simple. Say E is our main package in this particular case, and A is like the base package that everything gets imported by. If package B updates, by the way, if package B is the thing that gets changed and we're trying to do minimum, like we're trying to do this incremental builds, anything that depends on B must also be updated. So in this chain, A and C are unaffected by B, so they just remain the same, but B, D, and E all get updated. Yeah. Again, family friendly. We try not to talk about getting off my knees and then talking about package. This is how things go. Now, this is where things are. So if anything happens in B, then D and E have to recompile. Now people go like, but why would that have to be the case? If it's just B was changed, then just recompile B, don't we? And this is the problem, is in general, we can't solve that because Odin has something called conditional compilation. Yeah, it's the problem of conditional compilation. Now, this is actually, this is the problem when you have a language that has it. You can't do this incremental like changing. One language that doesn't have it would be like Java. Now, Java is actually a brilliant example where they have their like package module system is very thing, and they don't have like conditional compilation. Things just work in that regard. But because Odin does, there could be semantic changes in B which now affect D and E, and you don't know until you retype check anyway. So you've got to completely type check it again. And even then, because Odin also has a minimum dependency system, that would also, which if we're doing incrementals, we may minimize it. We still have to have some of it, by the way. Sorry. Minimize the minimization, the minimal dependency system sounds a bit weird, but what I mean is we can probably just expand a little bit further out, just to make things easier. But okay, so that all works out. We've got conditional compilation is one problem. The other problem, as we've got, as I've already explained here, is we've also got parametric polymorphism, which I normally refer to as parapoly, which is parametric polymorphism. Oops. Right? And that's the other thing. So you may ask, what is that a complicated problem? And you go, yeah, so let's just actually make this really simple, right? We're going to reduce our example down to real packages. So we're going to have runtime package, and we're going to have the main package. We know the main imports runtime implicitly as well as also could be explicit. And let's say in our main package, we're doing an append call, right? Now, append is this built-in procedure that's written in user level code in runtime, but it's parametric polymorphic. It's generic. It's parapoly. So when we do an instantiation of this, for every single like dynamic array type that we're using it with. The question is, where do we store it? And it's a real good question. So currently, because we only want to have one copy of it, for like if we have like we're appending to the same type, like we're appending to like a dynamic array of ints and a dynamic array of ints, we only want one instantiation of that procedure, and we currently we're storing it in runtime, right? So what that means is if we update main and it doesn't use this, we need now also update runtime, which is a little bit annoying, to say the least, which means now we've got this back propagation of updates, which may have to happen anyway, but like in this particular case, it's a back propagation. We don't want back propagation. So what could we do? So one current thing I'm already explaining with, which I'm going to, is an internal flag at the moment, which I'm going to make into a non-internal flag, is we're going to split it into, that runtime package is going to be the specific code, which is a non-generic, you should say, and the generic code. So that means if we rewrite this code now, we've got runtime package, and we've got the runtime. I'm going to put a $sign there to make sure it's parapoly stuff. Remember, so we've got the this is the specific and then the stuff. So when we write like append, or actually let's go back to yellow. Append. This is imported in. It's stored in the runtime parapoly. Okay, and we've done that. Right, so that's where we're storing it currently. So that means we don't necessarily have to update the runtime side of things, like the non-generic code. But if any like generic code gets updated, we update the parapoly stuff, like the generic side. Now, some people are asking, and they're probably shouting at the screen right now, why haven't you considered doing weak linking? And what they mean by this, so I'm going to explain what they mean by this question before I explain what the problem is and why I hit this today and went, oh, really annoys me. So the weak linking option is not to have this, so we're going to get rid of that, is to say, well, we're going to have, when we do the monomorphization of the parametric polymorphic, good God, so many words, we store it in main, but we may also have like another package. We could say this is foo, right? We could have another package, foo, which also imports from runtime, and it may have the same append like a dynamic array of int. But what we're going to have is the same copy, like literally a copy of each implementation of append in each of these different packages. So in this one will be main and foo. So they'll be monomorphized on a per package basis. So what this means is when you come to link them, because append has got the same name in each thing, we just say they're weakly linked. So we only have to have one copy and ignore all the rest. Now that would be the ideal solution, because this means that runtime never had to store any of the parapoly stuff, and it only gets updated when that actually gets finally done. And then when these get updated and they change the stuff, they get updated because that's all the case. So you've got the wonderful monomorphization on a per package basis. You're done. So what's the problem? Windows linkers. So Windows, which is clearly the operating system I'm on right now, by the way, doesn't do any of this. And that may be a bit confusing to you, but you say, well, what do you mean it doesn't do anything? I'm like, yeah, it doesn't work. Like, you can't do weak linking correctly. And it's like, oh, now you think, oh, okay, that's the Microsoft link. That doesn't work. But what about, like, say, the new RAD linker? And the answer is that doesn't work either, because they're trying to be adherent to the actual other stuff. And when you do that, it doesn't work. So it just, okay. So the weak linking. Oops, linking is nope. So this is why I've had to go towards having that separate thing, and we're going to think about updating that way. So it's still not going to be great for incremental builds, which is hopefully what I'm planning to do. By the way, I'm not going to promise when it's going to come out, be finished, because it's one of those where I'm like, this is actually a really technically hard problem to do correctly. So by the way, even so, yeah, they don't support the type of weak linking that I want, which is like something like the GNU linker would also do. And again, the rad linker doesn't either, by the way. So the rad linker is actually, I would say, is actually a much better linker than the Microsoft one, but it doesn't work. So we can't have the weak linking approach. So I've got to settle some other approach to do the other things. So in this particular case, we've got to go to runtime. Runtime. What the go away. I hate Windows. And then you're going to have the runtime let's make that clearer. Poly stuff. So when we do have append goes into here, and let's say some non-generic one. I'm trying to think what a non-generic example of like let's say a non-generic thing. Let's say non-generic goes into that. So this is how I want to minimize. So it's not purely incremental builds. It's just going to be like incremental caching builds. So that's the plan. Now, I've noticed in the chat, a lot of people have been asking me, what happened to the tilde backend, or what happened to having a custom backend, or all this sort of stuff. And the answer is, and this is a proper answer, is like the tilde stuff kind of got put on hold because Negate, who's the creator of like the tilde quick stuff in general, got a lot busy in real life and he couldn't be working on it again. I think he's going back to it again to have some more time. And I had a lot of the time where I couldn't work on it either. But the other thing that I'm considering is that the tilde backend is great, but I kind of need to make if I'm going to have a custom backend, I'm going to have to write my own custom middle end, which is a little bit like, whoa. I'm like, yeah, so something I can then from that middle end trivially go down to something else. Like you can go back to LLVM, go back to tilde, or even go back to something custom myself. So you have this actual problem where with the custom backend, and please do not do more dick jokes in the chat, please, guys. But yes, that is kind of the problem that's going to be happening here, where you want to have this other thing going on. And also, thank you very much for the raid, Chris Titus Tech. Ooh, wonderful, wonderful. Right, so that's kind of thing. So this is why I'm thinking it's a question of what do I focus my time on? And I think incremental builds, or at least getting some form of caching going on in the back end, is going to be the better option for the short term to get. So even if we get a 30% improvement in compile times, that is a massive improvement, right? Because if we go back to what we're looking at here, the front end is this section here, and then we've got the back end from that point on is a mess. It's not really nice and multi-threaded. And if we can improve this and cut this down from, let's say, 1.1 seconds, and we can cut that down again, if we cut it down to this much, we've got an entire compile time of like a second. We'd be really happy for a massive project such as LiquidGem, which is what this is profiling, by the way. We'd be very, very happy. But again, unfortunately, I'm not going to please all of my colleagues who are saying this is too slow. Now, by the way, people are complaining like, why are my colleagues complaining so slow? It's not all my colleagues. In fact, it's only a few of them. A lot of my colleagues always say that Odin is extremely fast, and they go, oh my God, compared to the C++ projects we've been on, this is compiles so fast. And it's like, well, yes, it does, because C++ is shit. Short answer of it. And a lot of C++ projects are really shit as well. This profile that I'm using, by the way, is called Superluminal, and no, it's not free. You have to pay for it. Superluminal. No, not the Superluminal version. Superluminal, the profiler. Now, for a personal license, either $59 to buy, perpetual, once you've got it, for not dollars, that's euros, or I pay for the business one because I use it for commercial use, obviously, and that cost me €289 a year. And oh, is it worth it? I highly recommend Superluminal for profiling, like this kind of profiling. It's not like an explicit profile or an ultimate thing. This is just like a, how do I put it? It's a profiling profiler. It's hard to explain. It is absolutely wonderful, and I highly recommend it to anybody. You can get the free trial for 14 days, but yeah, Superluminal this is kind of what it does. So you can actually even see, I can even go down to all of this details. I'm like, oh, okay, I'm going to click on here. Oh no, let's go. Actually, where's a good example? Let's go to this section here, right? We scroll in and we can set, oh, it's checking procedure stuff here. We're going to check procedure body, and it even tells you all of the function lists of what it's being dependent on, what's their massive states. We can go all the way down. We can check to see in here, like we go into this procedure here, and if we zoom in, it even tells you where most of the time is taken. So this was a bad example. Let's go here. Let's go, yeah, let's go here. And it gives you percentages of what time part of the function that's even being dealt on. So it's a brilliant profiler. I'll give you that. It even tells you like the thread contention problems. Like here, there's some thread contention issues. So if we look on this, I could have guessed what this was because we were talking about it earlier. It's the adding dependencies to the children problems, and all of these are like what we have in thread contention in this code. But in general, that's a really, really well optimized bit of code for thread contention. And there's where the wonderful thing is. But yeah, optimizing things is a really hard, and I'm not saying optimizing like a right machine code. What I'm trying to find is where are the slow bits, and can I multi-thread them, or can I improve the speeds or anything like that? I'm just trying to get rid of the pessimization is the best way of putting it. I'm not trying to be optimized. It is optimization, but it's not like micro optimizations, if that makes any sense. So yeah, so for people understanding, the tilde backend is probably on the back burner, but I might rewrite a lot of it to be even more generic. So I want to like a middle end system. Again, it depends on what my time is. It's hard to deal with what should be done. Oh, this profile was made in C++ or C# or something like that. I don't think it's Odin at all by any stretch, no. Yeah, I'm having a very much good day. Nice to meet you guys. Anyway, so yeah, this is all the kind of stuff. So I wanted to actually show you one thing where I can multi-thread one little section of the compiler already. So I wanted to kind of show you this. I am the original author of the Odin compiler because I am Ginger Bill, if that's what you're asking. So yeah, but this is not my full-time job per se. I work at Django Effects, so I work on a lot of the Django Effects projects such as Embergen, Liquidgen, Geogen, and Illugen. This is profiling Liquidgen at the moment is what I'm using. At the moment, I've been working on the Odin compiler quite a lot rather than the actual projects, because I was working on like actual code at the moment, which is like testing frameworks and such we were working on. But I just want to try and get more work on the compiler side of things because it helps my colleagues and also other people who use Odin. I did the calculations where I figured out on a weekly basis, we're probably in the range between 10 to 20 hours of just compiling code as a company. That is just what we're doing and that's just Odin code. That's not to mention any like we had to rebuild third-party dependencies and such. 20 hours a week with just compiling code is quite a lot, but it's nothing compared to some companies, by the way, where they'll be spending thousands. But for me, I'm like, okay, so for us, that's 20, because if we've got a team of, 15 programmers now? I can't count. I'm not counting in my head. That's boring. Counting's boring. Don't do it. It's more of a question of how do we minimize that time? Because we're wasting a lot of time. Like if we can cut, instead of 20 hours of wasting, we can get down to 5. That would be amazing. But here's the other thing is, if we can actually we may not be wasting that amount of time. In fact, if we can recompile quicker, we may actually, again, we can recompile more. So that 20 hours may still remain 20 hours, but you've recompiled even more and you've actually had to test things quicker as well, right? So you've not got this delay of waiting for it to, I've got to wait for it to compile. Right, now it's working. And that delay is where you want to improve people's productivity cycles and such. So that is a very in-person thing. So not 20 hours per person, that's 20 hours like across 15 people a week, like 5 days a week. To explain what I mean by that, I can calculate the estimate, by the way, it's not that difficult. I kind of made up numbers in my head and went, yeah, that sounds about right. So let's say the average person on a team, it takes them 5 seconds to compile a project, right? We say it's 5 seconds. And they're probably doing it 100 times a day. That's So that's 500 times, that's 500 seconds a day per person. Right, let's get a calculator up, right? So we've got 5 seconds per thing. They'll probably be doing it 100 times a day. Oh no, is that 100 times a day or 100? I'm trying to figure out how often they compile. And I'm saying this is a minimum, by the way, an absolute minimum. So let's say it's 100 times a day, times by 15 people, divided by 60, divided by 60 again. No, that was, oh yeah, sorry. That's per day, times by a week. Yeah, you get 10. So that was a minimum of 10, I was thinking. But 100 times a day is nothing, right? I probably compile more than that in probably an hour. So if we times that by, again, it could be anywhere from 10 to 20. I was thinking 20 medium, but like, it could be wasting 100 hours a week on a team of 15 people. And like, that is a lot. And this is where things, so someone says, how much slower compared to C compilers? So here's the problem. You can't actually compare this to another language. Because literally the entire compilation model is different. So when you compare it to C and compare an Odin to C, it doesn't really make any sense. Because C is actually a single threaded build system. Like if you look at it one like compilation unit, it doesn't get multi-threaded except when you get to the linker stage. But everything else, but then you have multiple like usually build units and it goes faster. So you get this problem of that's not technically true. Yeah, this is what I mean. This is when I said 100 times a day is a minimum. So you're wasting a minimum of 10 to 20 hours a week per person, but it could be 1,000 times a day you're compiling. So then you're wasting 200 hours a week, right? So me spending 40 hours for like a week trying to improve this is going to be a massive boon to people's productivity, right? This is when you have to think about from a business standpoint, like I'm actually saving people time. This is why optimizations help people, guys. I don't think some people go, oh God, actually this helps. And that's the kind of thing. This is why I'm focusing on this. So I haven't actually gotten to code yet. I haven't even typed any blooming code and we've been streaming for the past nearly an hour. Yeah. And I'm thinking not just the thousands, it's the tens, if not hundreds of thousands of people who are using Odin as well. So this all piles up. And it's one of those things that I wanted Odin to be multi-threadable and be fast to compile in the front to begin with. And this little block here kind of proves it, right? This shows you a lovely, look how well distributed that code is. It's extremely heavily optimized. And the thread contention bit is in the technical problems where I'm like, yeah, you're updating a tree and that's going to be a back propagation problem where you're going to have the thread contention. But it's lovely done. So it proved me the case. But Amdahl's law is hitting his fucking badly. And yeah, that means we just need to actually do like improve the code, like literally improve the thing to minimize that as well. Like if we can actually improve that, that'd be great. But the monstrosity, which is this bit of section of code, is LLVM. Now, if we can improve that, look, there's no load distribution nicenesses. There's loads of thread contention going on there. It's not good. So that's the bit I want to slow down, like improve. If we can do incremental builds there, that'll be great. Now, I wanted to show one minor bit in the code base where I think I can improve slightly by like 10 milliseconds, guys. 10 milliseconds. Wow. If you're doing a game, that was actually a massive amount because if you're doing 10 milliseconds per frame, you're fucked. But this is a bit more like bandwidth intensive. God, 8 seconds. Oh, God, that's because it's cold and I'm on stream. This should not be 8 milliseconds. This should be in the order of 1.7. There we go. Much better. Phew. Right? But the section I want to slow down is the LLVM initialization. Is this section here. So global variables, initialization, all that lot. We can improve that. So yeah, there's all this we can probably do to improve things. And that's going to be in LLVM general init module, right? So this init module thing, I'm going to go LLVM backend module. I'm going to actually, one thing I want to put on here is checker. Each module we create should have a checker on it, in fact. Yeah, and I'm going to go do that. Is there no, that's all right. It's going to go, bleh, bleh, we don't want to do that. checker equals C. Yes, every module we initialize is going to have this same thing on it in the code. So let's just get rid of the thing there. Like that. And then we want on there as well, don't we? So we want PM for that, and we want PM for that one. Yeah, so that should now, it's going to complain at me because I've not done that correctly. Fine, and then there's an int module there. Add the checker in there, and there we done. Great, that's wonderful. I'm going to thread pool wait. I'm going to explain what I'm going to do is I'm going to do a thread pool approach here. So this init module thing, I'm going to change it to be a worker task proc, and then lb module m equals, we're going to cast that. So we've then got all of that, right? So that's all in there when we wanted it, as we need. It's got to return a value, so we return 0 because it's just a worker thread. Right. This is where things get a little bit fine. And what I'm going to do here is, let's call this worker proc rather than init module. And the reason as to why I'm doing that is I'm not trying to multi-thread it completely. Let's do init module lb module m, and I'm going to call it in there. So now everything's kind of wrapped correctly. We're going to do this divide and conquer approach, and the divide and conquer approach is effectively, are we going to be multi-threading or not? And when we look at the do, there's a LLVM backend, do threading, and this do threading for here is we get defined. So I'm going to have the bool do threading passed around everywhere. Do threading, do threading, do threading, do threading. And yeah, let's put do threading on there as well. So why is that failed? Init generator, oh yeah, bool do threading. And now it's going to fail here because it's going to ask me if we're doing threading in the init generator, which we don't need to have that as a parameter. I just realized. We can recalculate this value here. It's not really actually a real big problem, to be honest with you. Just read. It says worker count. Let's do all that. Just recalculate. It's not a problem. And then do threading has been recalculated. I'm like, yeah, I know. So I'm going to get rid of that. For the time being, this will be fine. Now, this is where the simplicity of doing a divide and conquer approach comes in. So if we're doing threading, we just do that. Else, we just call it straight away. But the way we do this is we add a add task to the list. So the task is going to be that the worker procedure plus the payload, the data we put into it. So once we do this, we now got do threading on by default. And then, hey presto, does this work? No! The question is, why doesn't this work? And I'm going to look at this because it's probably not as simple as you think. Again, this is just a minor optimization that I'm doing, which is probably not necessary. The creation of these things, creating context, doing that, we've got all of that be created. Right, so that is actually weird. Okay, so I don't want to test that, but I do want to, let's change this to liquid gen. So I'm going to do that test build. And it's crashing somewhere. Oh, that's why. So that's my fault, because I'm trying to do something multi-threaded when I shouldn't. This is LLVM for you. It's Paul. So poorly written, and it is. I'm sorry, I'm not afraid to say that. That if I do that there, yeah, that works now. Right, so I'll just where I need to wait, because then this has to be done in the main thread. The rest don't. So this is probably taken off a few milliseconds. That's all it's done. Whoa, what a few milliseconds to web guys. So if we actually, to prove this, if we looked at this profile here, right? We go back to our main thread, and we were looking at the init generator code, which is here. This whole 21 milliseconds we were looking at. So if we rerun this code to do what we wanted, the camera's frozen again, hasn't it? It's overheating. Right? You just got to see me now look like go, I love technology. There's nothing wrong with technology. Technology is perfect. Again, sorry, it's not the camera. Sorry, it's not the camera that's overheating, it's the camera capture card. So if I do the full camera again with me doing this, deactivate, activate. Oh, I'm blue. Oh, I've joined the. I blew myself. Oh no. Oh. Sorry, I'm keeping with the dick jokes. You know what? I'm going to keep it at this color. It looks awful. I'm a Smurf. I'm a Smurf. What's going on? Yep, it's still blue. Yep, I'm still blue. Right. Let's just stay here, right? I'm fine, right? I'm in Aladdin now. I'm gonna be a genie. That's gonna be fine. That's gonna give a character some wishes, or I'm just Papa Smurf. I don't know. Oh, good God. Yeah. Let's go back to programming and just see how blue I am. I'm not Ginger Bill anymore. I am Blue Bill. So, Ginger Funke. Yes, that's correct. I'm not Tobias. I'm Ginger. Right, carry on with this. So, this is the renew generation. So, we looked at this and it was 21 milliseconds for the init generator. We go back into this code. And can we find it anymore? Generate code. Init generator. Here we go. This section. It's very multi-threaded and it's gone down to 18 milliseconds from 21. Wow, is that good or not? And the answer is probably not worth it. And it doesn't even look like it's multi-threaded to me. What? Yeah, they're all single-threaded still. Oh wait, I'm in the wrong code base, sorry. There's the multi-threaded. And yes, and you go like, oh, a lot of these are on the single thread. A lot of them are distributed, and you go, ooh, there's a lot of thread contention going on here, right? I'm trying to explain how you read this kind of code, this profiling. And you go like, oh God, there's a fuck ton of thread contention. Why is that? And it's actually quite easy to look at. So if you click on one of them, see where the thread contention pops in, a lot of this is just waiting for the actual data because there's so tiny little bits of things to pop on. They're not working. But other ones are actually a lot simpler to calculate, and they're actually simpler than you think. A lot of this is just waiting on the heap. So we're using a heap allocator, and the heap allocator is causing problems because the heap allocator has to be locked with a mutex to make sure everything's thread safe. You can't have a heap allocator per thread because don't ask me. Yeah, but it just doesn't work. And yeah, this is what, again, sorry, it's really weird looking at me at blue. Like I blew myself. What's gone wrong? This is, we've started off with these jokes and we're going to end with these jokes. Yeah, I'm eating silver. I've got this silver poisoning right now. This is what's going on. Like clearly I'm not doing this. It's just I know what's clearly gone wrong, and it's just, I bet some of the channels have just swapped, haven't they? That's all it is. Let's undo it again. Let's go back on my knees and yeah, so that just cut out for a second, which is exactly what I was expecting. And look, I am back to my ginger self. Ah, that is wonderful. Wonderful, guys. Oh. Whew. I don't feel as bad. I don't feel blue anymore. It's relaxing. Back to the actual colours. Now the thing is, that blue could have been my orange. You never know. It could have been. That's how the qualia goes on in this case. But yeah, that's it. But again, sorry, all this thread contention problem stuff here is fundamentally stuff we can't actually fix, because it's any time we use the RTL alloc heap function, which effectively internally, when you look at the code, oh look, it's calling a critical section and it's going to be slow. Yet there's not much I can do about that. So even though we've gone from 21 milliseconds to 18 by multi-threading this code, was it actually worth it? And the answer is probably not. But now we've got a less sea of red. A bit more green in there. Because, of course, we're redists and we prefer green over red. And for people who are like red-green colorblind, yes, you're even worse. You're more redists than the redists, in fact. And yeah. So why does that have to be heap allocated? Now, that's a brilliant question. All of these that we are using heap allocators for are dynamic arrays and maps, hash maps. And those things I have found, you want to use them to minimize memory usage. So we're already using 2 gigabytes of memory to compile LiquidGen when we compile. That's a lot of memory, using 2 gigabytes per build. You think, shit, that's a lot you're wasting. It's like, yes. So to explain what's going on here, we go pick up Milton again. Woohoo, we're going back to drawing stuff, guys. With a heap allocator, it does minimize memory usage, right? Because let's say you got a hash map and we double it every single time. So we'd say it's got a length currently of n, and we go to another capacity of n, it goes to 2n, and then the next one's going to be 4n. The next one's going to be 8n, right? That's what sizes grow when we're doing exponential growth. Now, if we just did a linear allocator and wasted memory all the time, this becomes the sum of 2 to the n, right? And we're going to do that to the up to k. Now, if you do this correctly, this actually becomes 2 to the k plus 1 minus 1, right? So just to make this through, if we add n, this is n starting from 1. Is that right? Or is that starting from 0? There's yeah, it is of that order, right? So you get this problem where you're actually effectively wasting twice as much as what you needed. Is effectively what's going on. Someone's saying, why didn't you just pre-allocate memory per thread? And the answer is we can't do that because we're not just using a linear allocator, we're using heap, because you've got multiple different hash maps and dynamic arrays. So when we look at this init, oh good God, what am I doing here? Oh, yeah. Init module code, we've got all these different hash maps. So we've got, where's the init module? Yeah, here we go. We've got different hash maps. Like we've got the types, the raw func types. This is all bunch. Another map, another map, dynamic array, hash map, dynamic array, hash map, dynamic array, whatever. So you've got all of these things where you want to minimize the memory usage you're doing, because that 2 gigabytes could expand to 4 gigabytes trivially if you don't do that. Now, some cases with the linear allocators, like if you're doing an arena, that's fine. And because it's all about knowing the lifetimes of your problem. And most allocations within Odin, so I'm flashbanging you right now. I'm going to go to my own article series to explain this. So if we go to this thing here on my article, again, I'm going to flashbang you with light mode, I'm sorry, is knowing about thinking about allocation. So when it comes to an allocation, there are 3 main aspects to think about. It is the size of the allocation, the lifetime of the memory, and also the usage of that memory. And when you're thinking about things, usually you're only thinking about the first two because the usage is obvious. So usually you're thinking about those first two opposite on the table. And for most problem domains, these percentages, which I've kind of found like empirically through projects I've dealt with, kind of show you what they are. So when you've got a known size and lifetime, you're using an arena pretty much. And that's what I was talking about, linear allocations. But unfortunately, the case that we were hitting here, which is with the hash map, we don't know the size. We know the lifetime. Oh god, the lifetime's obvious. It's for the module. Like that's the module is the lifetime. We don't know the size. And this is where we need to do like a heap kind of thing, because we want to minimize the size as well. We don't know how much we're going to be using, but we don't want to waste it, because we could trivially waste it if we just kept doing like a heap, an arena. So that's kind of the better option. Now, someone's saying, why not use a pool? Because the thing is, we're not allocating little individual elements, which is what pools are perfect for. We're allocating giant hash maps, which is not individual. That's just a giant thing at once. So something like malloc is actually a good option for this. And that's the way I'm saying you get the 95 and 4%. Within the compiler, we have literally 0 cases of like garbage collection or reference counting whatsoever. And we've got, we never even hit this. This proxy 1% does happen sometimes where you do need like a kind of reference counting, but in a compiler, it's again about 95% linear allocations and 5%. It's actually about 5% of heap allocation, I'd say. But you want to do that because those 5% will become to dominate the actual amount of size you're using because it's unknown. Does that make more sense now? Hopefully that carries on. Yeah. Now we're not flashbanging you so much anymore. You're welcome. I don't know what. I can't think of a joke for this. Yeah, not really close enough. So again, when I'm saying there's hash maps work well in arenas, the type one, yes, this already grows, but again, the problem you've got here is you're going to be wasting twice as much memory, as I was explaining earlier. Like to grow your hash map, you need to literally copy and paste it into another one that's twice the size. So at worst case, you're literally wasting twice as much memory than you actually need. So yes, they don't work badly. I'm not saying they don't work brilliantly with an arena. It's just that you're wasting memory, and I don't want to be wasting memory in this case. And a hash map is where you're getting your problem. But hash maps, but this is the only case, because it's in other cases where you can get around using arenas for everything. This is just like the case where, like, I think a lot of these dynamic arrays, I could probably turn these into like linked lists, and they'd be performant as well. It's just that the hash maps are the biggest problem. So if I could minimize on the hash maps, that would be great. Oh yeah, there's one with like linked lists. I know what you're talking about, but yeah, I'm not. Yeah, but the problem is I kind of want to also iterate across these hash maps as why I exist. They're not just there for other things. I understand probably I can guess how he's using it, but it's still not going to be nice. It's still going to be slightly wasteful of memory is all I'm going to say. My guess is. Might be wrong. Yeah, someone said, I was just reading that. So me malloc must have a much better handling of thread contention. The answer is yes, it would do. But we're not using that yet. But again, I don't think that's the biggest. If we look at the performance stuff, it isn't in general our biggest bottleneck. Again, our biggest bottleneck at the moment is this section, which is called LLVM. It is more than 50% of the code is LLVM. There's some beautiful things, like for instance, this little section here is just the parsing. I have done no optimizations with regards to parsing other than multi-threaded. And it's taking up, in real terms, like 40 milliseconds, 30, 40 milliseconds. It's tiny. They're like a 500,000 line project. Fucking hell, who cares? Like I thought about optimizing. I'm like, but then you're optimizing nothing here. It's just this part of the front end bothers me, as well as this little bit here as well. And then after that, I'm like, yeah, this is a mess. So if we can, is there any other places we can optimize? Because I'm going to commit this right now. These changes. Also, I'm using File Pilot, a brilliant replacement for your File Explorer. So yeah, let's just say this multi-thread module LB module init. So that's what we did. And we did live on stream. Wow, the amount of code I've actually done. That's why I did it, okay? What if I just... Oh, I've merged something in and I didn't... I know, it's my fault. I did merge to put PR before I did the stream. Right, there we go. Problem solved. So when you're saying, I really love how much there's masturbation around parsing in academia, and in practice, the fastest part of any programming language. And yeah, it is. So the thing is also my advice for people, and I'm just going to get off my screen because let's go to camera. Let's go quite personal with the camera. My general advice is when you're learning parsing, is to know recursive descent and prac parsing when you want generic like binary operators. So recursive descent and prac parsing is all you ever need, pretty much in practice. All of these other fancy parsers that people need to learn are practically useless. So when people are learning how to make them faster, sorry, I do use TortoiseGit, that's correct. I like TortoiseGit, I like Tortoise SVN as well. So people just all use this, learn about all the fancy things like, the academia focuses on the parsing. And if you're doing something like, let's say, regex, like regular expressions, you want to actually have like a nice, that can go fast because you want to optimize on that. But for general grammars of most languages, you don't need it. You can be fast just doing the dumb thing, which is, again, recursive descent plus prac parsing. And I don't think even that, I don't even class that as dumb. I just class that as, that's the only same way to maintain things and also give decent error messages. Another thing as advice is I would never recommend a parser generator. Parser generators sound like a good idea, but in practice, when you use them, it means you now cannot have decent, I'm trying to rephrasing this. You cannot have decent, error handling messages because it just generates code and then you're like, oh, but I want to modify it. So even when you've done this, it's like by the time you've modified it to have decent error handling, you could have just written yourself from scratch and it would have had better error handling. So yeah, there's a bunch of stuff which is just a complete meme in like parsing and such. But as you could see from the thing here, parsing was literally no time at all. It's this 40 millisecond thing. 30, 40 milliseconds. In fact, it's 30 on without a stream, 40 with. And when you do have this, if it's cold, it's not like cached in memory like the files. That's slower, but then you're bound by I/O, not the parsing. And again, I've not optimized on tokenization or parsing or anything like this. I know hypothetically, I could get that down to 10 milliseconds, right? And I mean by hypothetically, it's like, all right, I'm going to do a better high performance tokenizer, then do the proper parsing, we do all this. Like, I'm like, but saving 30 milliseconds is not worth it for that section when there's 30 milliseconds I can save elsewhere in here. Much, much easier. Good resources to learn recursive descent. Not yet. I'm writing it. So this is a bit of a tangent. I know some people saw my little project I was working on literally on Sunday, which was called Titania, right? Titania. Tit. And this is a language that I'm basing on Niklas Wiet's Oberon 7 compiler language, and I was going to modify it slightly, modernize it in certain ways, like certain more modern features, or even certain things. I even might have like semicolon insertion rules because I want to do that just so I can show people how to do it. But the whole point of this this language that I'm working on is, and like when I do it, is to the Bitwise by Per Vonsen. It would be a great example of it. Yeah, Bitwise is great. So Per Vonsen, Bitwise. There we go. Here we go. This one. This was always a good code series to learn how to do like parsing and such. But I wanted to do one that was like from scratch as well, because he had different goals and stuff in mind. This entire language, I've pretty much nearly done the front end. I think it's about done. I may tweak the language. It's not ready for like use. I wouldn't recommend it. It doesn't even have like a backend yet. But the whole point is I want to go from like, okay, this is how you do tokenization. This is how you do parsing. This is how you do an AST. This is how you do type checking. This is how you do like a type checking that would scale to a better language as well. Then this is how you do code generation. Specifically, I'm going to be generating assembly code directly. That's the goal, to go straight to assembly. So into generating a Windows AMD 64 machine code for a P file like .exe. That's the goal. So that was the idea with this language. I haven't done the back end yet. When I've got time, I'll flesh that out. But this will be fun to do, to see how things go. I'm not transpiling to C. I'm going to go straight to machine code because I want to show people how things work. And then you can see how to do the C thing later, because that's the easy thing. Once you've seen the hard thing, the easy thing, which is C, oh, that's really easy. I'll deal with that. But again, one of my real general things is I think a lot of programmers I've found over the years do not know how to do any parsing whatsoever, let alone, actually, they don't even know how to do tokenization, right? They'll use regex for everything. They think regex is the solution for everything because that's all they know. And it's like, regex is virtually, you never want regex. Like literally, you very, very, very rarely have regular expressions. And the funny thing is, even when you have a grammar, which is actually regular, which is rare, the problem is that assumes there's no errors going to happen. And when you have errors, in the grammar, that means your grammar is not regular anymore. So in general, you don't want to just assume everything's regular. They kind of want a non-regular grammar, which again, something like recursive descent works beautiful for, right? So you have this much better approach going on. But once you understand recursive descent, you understand this recursive nature to things. So if I was going to show the Titania language that I've done here, you'll show the recursive nature of how these things build together, because the grammar, reading grammar like this can confuse people, and it does confuse people, but there is a recursive nature to things. Like here's an if statement, it's got an if token followed by an expression, and then the statement. If you look at an expression, we look at where an expression is defined. Oh, it's a simple expression, which also has a repeating either relation or a simple expression. We'll go down to there. Oh, it's an honorary expression. I need to get rid of this. That's wrong. Oh, followed by this and this. And it's like, and you keep following it down, and it's just recursive. Like you get to an honorary expression, gets you to a term. Term gets you to a factor. Factor then gets you to this, but actually gets you back to an expression. Oh, there's recursion. Oh, who'd have guessed? So you have this lovely, again, it is recursion, what's going on. So learning assembly, I'm not even going to teach assembly in this case. I'm going to teach machine code, which will teach you assembly. That's kind of the idea. I haven't planned this out yet. This is a plan. I was going to be probably doing this in a couple months' time. Like when this went on top Living Hacker News, it really kind of annoyed me. I'm like, guys, this is not even 24 hours old yet. Can you please stop? Like this is me planning out the language, figuring out this is what I want for the language, because the whole point is I do not want to be doing language design in this course, because language design is a different discipline to making compilers. And I think that's something a lot of people may not understand that it is. So yeah, language design is a very, very different discipline to compiler design, but because they're related, but not exactly. Like you can be a very good compiler implementer and be awful at language design. To be good at language design, you have to be a good, not great, but good compiler design. Because I don't think I'm that great, right, compilers, to be honest with you. But you still need to know how to implement and also understand the basics. But language design is, I think I'm a good language designer. I don't think I'm necessarily great. I think there's much great language designers out there obviously than me. But to know the skills that you need to do it is a different skill set. And I don't know how to, I would teach that to someone, because you kind of have to learn a lot about other things. Like you have to learn, I would say for me, psychology is a lot of things you have to learn about. Like how people actually take and use things and different philosophies of approaching things, because you can design languages to have like a certain model to like enforce certain semantics in a language, but you could also be something else. You could actually simplify it in other ways, if that makes any sense. Now I'm going to go bed in a few minutes because it is literally 25 minutes to midnight for me. I'm a little tired, just a tad. But yeah, this is one of those where that was the idea I'm saying. So yeah, you can see what I was doing with the optimization of the compiler. And it's just like, look, this is Odin. This is how the compiler works. And then I designed Odin so it could actually even be multi-threadable and be optimizable as well. And I think that's also a lot of things when people come to design like newer languages, they don't usually take that into account because they've not had the experience of making languages before. Because this is one of my things, you have to understand, Odin's not my first language by any stretch of the imagination. Probably like my 20th, I think. Like something at least 10. I've done at least 10 to 20 before. And like Titania now is like probably my 30th. And again, I'm basing it off a language that already exists and then tweaking it to be what I like. So you have to understand what you're wanting from this and everything like this. Now, if someone's asking how often do I be streaming, I have no idea. It's when I have time. Like, this is random, I know. Behavioral psychology does play a role. Yeah, that's correct. Because a lot of the time when I'm designing Odin, I'm looking at how people actually interact with a language. Also with how they model it in their own mind. Because what they think goes on isn't necessarily the rules. And then you have to make the judgment decision of, do you lean into that model, or that intuition or instinct that people have about how the language works? Or do you go, no, I'm going to actually be very like abrasive and create a lot of friction here that tells people, no, it goes against your mental model, but like there's a good reason why I'm going against it. So you have to understand where you're going from this design perspective, because it is very weird. In many ways, I guess it's probably close to like game design if we're talking about another thing in programming, because you're actually questioning is what you're trying to navigate. Now, some people may say, oh, you're just not allowing the freedom of the programmer here. You should just allow the programmer the tools and let him decide what he wants from it. But the thing is, that's not true. Like a well-designed tool is actually very opinionated. And when you have something that's well-designed, and it's like, I've got, randomly, this will sound weird, I've got a pair of pliers in my hand. These are nose hair pliers, right? These are really cheap ones from Halfords. Like Halfords is a store in this country in the UK, which, yeah, it exists. But like, if you look at these pliers, they've actually got certain aspects to them, which is on purpose, right? They're shaped to be, they've got a curve to them. They've got the grips in them, both not just grippy here, but grippy there. So you can also cut wires with them. They've got the scissors on there. They've got the handles, right? They're at a certain angle, so it's already gripped in your hand, so it's bulged out, so you can squeeze harder. They've also got the shoulders on them, so it doesn't keep slipping off your hand. This is actually a design thing on purpose. You could just say, well, we just need the basic thing. It's like, no. When you design something, you need to be case. Like I've got another pair of kind of pliers, but these are very differently designed, right? And if you look at how these are designed, they've got the bulge in them, right, already, so it's easier to grip and easier to pick up as well. When you're picking them up, they've got a grip. That's why it dual function. But they've got different design to them, right? So you've got, these are the nose, and they've got bend to them, they've got the grips, but there's no bend to them. They're very flat because they're meant to be doing a different purpose for these different set pliers. They've got the grips, they've got the cuts, that's fine. They've got another grips as well down here, but they've got very little shoulders to them. So you think, why do these have shoulders to them and these don't? Because they have different purposes. These, you don't need the shoulders because you're trying to hold them in a different position to where you would be holding these. And that's where it's like design comes in. Like even the simplest things when it comes to like pliers will have that aspect to them. And you want to nudge people into the correct way of doing it. And then again, like the shoulders are nudging people away. The length of these like arms are nudging people another way. And that's when I've always kind of tried to design Odin. Where I know a lot of people always want, well, just let the programmer have freedom. Let him decide what he wants to do. How dare you be opinionated? And it's like, I think I've got good taste, I think, hopefully a lot of the time when I'm designing things. And I'm like, no, I'm trying to nudge people out of the bad things, not necessarily, or nudge them towards a better way of doing things. There's still a lot of freedom in Odin. Unfortunately, like bad design decisions I've had like in there, which I can't really get rid of, or ones which are like bad, not bad, but like they've got different trade-offs which work in certain cases, and it's like, oh, how do you deal with this? And it's hard to deal with, right? But that's the beautiful thing of like programming language design, right? It is fun. Like if I was to redesign Odin now, I would probably do some minor changes here and there, just like another way of like, could I redefine the hierarchical approach to the like, could I make the global scope more multi-threadable is what I'm saying. And the answer is I think I could, but I don't think I could redo it now without breaking everyone's code base. I could have to fundamentally redesign the semantics of the language. But that's what happens when you try and make languages. You try and be conservative in your design, which is what I'm trying to do, rather than be radical about new ideas that have never been tested. And again, a lot of new languages do that. They always want to try the newest ideas. And I'm like, Odin's really like, the new ideas that I've tried are usually always have been the failure. And the ones that I know that have worked, they've worked, right? It's the kind of different approach. Yes, Odin does use recursive descent and prac parsing as well for the binary thing. So if we want to look at the actual Odin C++ compiler, I can just show that, right? So we go to Odin, we go to parser. Right, let's go to, I know, the binary expression, right? This is recursive descent. Actually, that's not the binary parser. I want to go here. This is purely recursive descent. And in fact, this is a prac parser as well, specifically. So we're parsing an unary expression. Then we get into a loop. We check to see if there's a token, the operator here. And we get to see if there is a precedence rule. Like, is it the same level? Is it less than the one we started with? If so, we break out that rule. This is prac parsing, right? This is how simple prac parsing is, and it's wonderful. But then look, we go recursive, like parse expression, parse expression. This is recursive descent. There are places in the compiler where I have had to get around recursive descent because some people have put actually pathological code into the compiler. This is, I'm not trying to like insult the person who did this, but like I had to do this because someone was doing this. Someone actually wrote code where they had 1,000 if-else statements, like an if-else chain. And when you do 1,000 times in the way I was doing if-else, because it was recursive descent, we were getting Stack Overflows. And this guy was clearly a beginner programmer. He didn't know what he's doing, but I'm like, how the hell? The way he was writing his code, I'm like, the guy didn't know algebra. That was the best way of explaining it. The guy didn't know algebra. He was checking every single case. It wasn't exactly, it was nearly that meme where people go, is it even? And they go, if I equals 1, false. If I equals 2, true. If I equals 3. It was honestly similar to that. This guy didn't understand algebra. But because of that, we found a problem in the compiler. So I made this not recursive descent. I can see there's a label here in the C++ code, which we then go back to. So if we have an if-else chain, we can just do the recursive. So instead of relying on recursive descent for an if-else chain, we can inline the tail recursion manually with a simple for loop like construction using goto. Now in Odin, we don't have goto, but we'd have a for loop, which we just go continue to that and be fine. It's quite simple. Yeah, will I rewrite Odin someday? The answer is yes, but not anytime soon. The official position for Odin is literally, I think most time bootstrapping is just masturbatory pleasure. It's not actually a practical use case. That why the hell would you want something that's unstable, or relatively speaking, I should say, and then implement the thing that you want to do with it to reboot itself to do that thing that, like, you'll have a bunch of bugs. Bootstrapping causes you problems. It's a hell. If you've never actually done bootstrapping, you usually have to implement bugs to get around the bugs to then get back rid of the old bugs. It's like a horrible, what you're doing here. Yeah, Odin doesn't need goto actually for this specific example here. Like if I wrote the Odin example, the if else chain that for, and then when we got to it, we'd literally just go continue that. So let's say, so if condition like that, and then after this, we just break out at the bottom. They just break out all of that as the normal code. So that's effectively emulating the goto in this code, right? But the emulation, it effectively generates the same code at the end of the day, but like we don't need goto. This is one of the funny things is when you have a lot more structured control flow in a language, you go around those problems. Someone saying watching your work is quite refreshing. You're 45 and you've been programming since 12, and I believe my day's job has been choking my love for craft. Especially through some live is reinvigorating. Thanks. Oh, thank you very much for that comment, man. Thank you. Could you ask how do I save live video? Well, I'm going to probably post this onto YouTube afterwards, so that should be no problem. Hopefully that's fine. How and when did you get into programming, and why did you choose it over physics? Okay, so I got into programming when I was about 10 years old. Like my first... I was always into computers. My dad always had computers around. Like literally there's like a picture of me like being 2 or 3 years old sitting at a... It would have been an Acorn Archimedes, specifically, I think. And then eventually we got a RISC PC as well. So that was like, so yeah, by the way, I wasn't using Windows at the time. Like, I'm not actually that old. I've given away my age at the moment. I'm 30 years old. I'm quite young, actually, in the grand scheme of things. But yeah, my dad was kind of from a very young age, he distilled in me the hate of Bill Gates. He hated Bill Gates that much. He would refuse to get a Windows machine. So we had RISC, like ARM, like Acorn machines, like the ARM RISC machines, which are now known as ARM. And then eventually we got like the original like iMacs. We had that like whatever was like a turquoisey bluey. I can't remember. It was like a greeny turquoisey blue, that kind of color, like one of the original iMacs before they had the multiple different colors. And then eventually we got a Windows machine just to play some games. That was all we had. But yeah, that's how I got into it. But then when I got into programming, I got into it because I wanted. I was doing some stuff at school. So when I was at primary school, I was effectively their technician, which is heavily illegal, I think, looking back on it. But I didn't care. I got out of lessons. So I was fixing their fax machines and their printers and the projectors and all that lot and computers and all that stuff. So it was quite fun because I was good at computers. And then I remember once I was trying to learn some, I would say this is technically my first experience with programming, was learning batch scripts and doing that. But then my first programming language properly would have been Game Maker. So I wanted to make games. Yeah, Game Maker language, GML. That was a monstrosity. And then after that, I think I started learning languages. So I started learning like Pascal because my dad had an old book on it, and then like C as well at the same time, and many other languages. iMac G3. It might have been the iMac G. It was the original iMac I remember having. We were on. Yes, it must have been the G3. Yeah. That was it. So they'll come out experiences were at 10 making games, and then eventually did many other things like other languages, trying to make websites and servers and Minecraft mods. That's why I started learning Java. So I learned a lot of languages. I also started learning like compiler stuff because I was always interested in linguistics. That's kind of a little story I got into. So that's how I got started. So why did I choose it for physics? So I got into it. I wanted to be a physicist. I became a physicist for a while. And I quit it because, well, how do I put this? I quit academia because I didn't like academia very much myself. It wasn't for me, put it bluntly. Then I got a job as a, how do I place this? It was a software engineering job / physicist / engineer. So like I was actually working on physical machines where I had to use programming, but also because I was an engineer, like doing an engineering job because I was a physicist, because I knew how to do all that stuff. That was really quite fun as well. And then I quit that job and started working at Django FX. I'm not explaining why in detail because I don't need to. But yeah, then I went to do this. So it's kind of more of a, that's how I got out of physics. I still love physics. In fact, Django FX is a physics company at the end of the day when you really think about it. But I don't really work much on that. I'm more of the like systems programming side nowadays, or the Odin compiler stuff. That's kind of my thing. So California 30 is the new 20. Ohio 20 is the new 40. I have no idea what that means. I don't live in California. I live in England. So yeah. So is that closer to Ohio? Maybe. People think I'm older than 30 just because I shave all this hair off and have a beard. Yeah. Is Django FX remote? Completely. Everyone is 100% remote. So I already said I lived in England. So yes. Like we have over 2 dozen employees now at Django FX, and we're all remote. There's not an actual office for Django FX. Like, well, there's an official one, obviously, but like, there's not a real one. Out of curiosity, what do you think are the benefits to the opposite approach, like how Mojo has basically nothing out of the box and everything is user space? So this is, okay, so Mojo, I'm not actually a big fan of its language design, and if people don't know, I'm not actually a massive fan of Chris Lattner in general. Chris Lattner's, how do I put this? I forgive him for LLVM because LLVM was a university project that just got bought by Apple, so clearly it went out of hand. So even though I moan about LLVM all the time, I forgive Chris Lattner for it. I do not forgive Chris Lattner for Swift or Mojo. Swift is a monstrosity which has literally the traveling salesman problem in its type solver. Sorry. What? Your type inference system should be constant time, or linear at worst, not n factorial. But no, okay, great. Then the other problem, but this is the thing about Swift. Swift could have been a really good language. Let's go full grammar. Right, let's do this. Swift could have been a really good language if it was just a syntactic improvement over Objective-C. Because Objective-C is unironically a pretty good language. most people who don't like Objective-C, it's just they don't like the syntax. It's not the semantics per se. Now, I know there are issues with the semantics as well. Like I will criticize them, but in general, it's mostly the syntax. So if Swift was just a syntactic improvement over Objective-C, it would be great. But it wasn't, and it never was that. And it's just this absolute insane language, which just keeps getting worse, in my opinion. And I actually prefer Objective-C over Swift to this day still. But luckily, you don't need to use Objective-C even more. You can just use Odin. Odin is a better alternative to Swift nowadays than Objective-C and Swift itself. You can do a lot in it because we've got all of the fancy features built into the language and the compiler. Because again, that's what Odin's pragmatic aspect is, right? This is the whole point. We have built things. You don't have everything have to be user space. We want tailored things that will just work. Trademarked. You're right, Todd Howard. I'm not trying to get it off you. But actually, our things do just work. But then the thing when it comes to Mojo to me is a weird language. So the first thing of aspect of Mojo is it was meant to be a language for AI, which was compiled, which had Python syntax. Now, originally we were thinking, what syntax we need to use Python, right? And that my point is, if that was just what Mojo was, that's great. I have no issue. Like, it's just got Python declaration syntax, but it's compiled. Great. I have no issue with that. Problem is the goals of Mojo are insane. They want Mojo to be a strict superset of Python. They want to run all Python code within it. I'm sorry, but no, don't do that. That's insane, but they're going to do it trying. They're going to strive to do it, and it's just a bad idea. Don't do it. So this is why I don't like Chris Latner when it comes to a language designer, because he shouldn't be trusted. He's made all these bad decisions already. Like, he's not a good language designer. I'm sorry, he's not. Like, I'm not trying to be rude. It's just he's not. Compiler designer, I actually don't know that much yet, because that's a different problem. But actually, no, it probably isn't, because if he's... it's probably a bit of both. But like, LLVM is not that bad, actually. Like, LLVM passes are actually good. Like, just the architectural aspects of LLVM are pretty bad. But that's a different problem. Again, I forgive him for that, because it was a university project that was kind of got out of hand. So yeah. Yeah, Django Practice is a cool place to work. There's all different roles. We all do kind of different things anyway. Some of us are like, some people are graphics programmers, some people are systems programmers, some people are UI programmers are going to be like, it's all different things for what we need. So someone's Chris Latner is good at getting things done despite bad decisions. Yeah, getting things done doesn't necessarily good, like, especially when I think he's literally said like evil statements of like saying embrace the complexity of software design. Like, he wants to make things even more complex and embrace that complexity. I'm sorry, that's evil. Like, I know I use it, like, people may know like package manager is evil. Like, I'm sorry, I'm using the word correct. Like, it's far from the good as entirely as possible. This is not what we should be aiming for, man. Just yes, RXI does work at JangoFX. He is the UI programmer. He is not the UI designer per se. He does a lot of UI design, but he's not the UI designer, because we have another as Vitaly who does that, which is he's not a programmer, by the way. They are different roles entirely, by the way. Like, a UI UX designer is one job, and the programming implements that is another job. And they should be separate people, by the way, in my opinion, because they are completely different disciplines. It's a wonderful team that we have at JangoFX. I love everybody there. They're great programmers, and yeah, it's so great. But yeah. We're not looking for new programmers at the moment at JangoFX. So at the moment, so we're fully, like, we're done at the moment, if I remember correctly. So we don't need any more. But yeah, we've got a whole different swath of teams. Like my job title at the moment, like, I'm honestly just saying it's God knows, because I don't always know what I'm working on that day. It's always, that's why I love this kind of job, because you do not know what you're going to be working on that day, or that week at least. So it's just whatever problems it is, you got to solve that. You got these bugs. Oh, I've got to fix these bugs. Oh, I've got to do some testing or do this. Or I've got to implement this new feature. Yes, do that. Got to go this new architectural thing for this new subsystem working. I'll go do that. Or fix something in the compiler, or add something in the compiler, or improve like this. This is what I love about this job, is because it is just a wonderful company to work for, and that But there's also this other thing, is you have to be very self-motivated as well. Like, we don't really have managers telling us what to work on. We have to just know what to work on, which I know a lot of people do not actually work that way. It's a very different, not everybody would work in that kind of culture. And it's not like a criticism of the people who can or cannot do that. It's just, it is a different, certain people can do the self-motivation, some people can't. That says nothing about the capability of the programmer at all, in my opinion. That's just a personality type, which is completely authentic, by the way. Most people think they would work well in that culture. They don't. I actually don't like it sometimes as well. Like, sometimes I actually want people to tell me, can you just tell me what to work on? Like, sometimes I actually want that. And I go like, God, it's really hard. I'm actually not, there's so much I could work on. I'm like, can you just tell me what to work on, please? Like, it's like, oh, we're working on this. Great, I'll work on that, problem solved. But that is where, like, a lot of people don't always know they think they can do that. Yeah, I think Mojo is going to be like a language which is not going to be relevant in general. I think it's just a hype language, really. This is the problem when you get languages. A lot of them are hype based. They're not like pragmatic. But that's the thing. This is the problem I have with Odin, with advertising, is it's not a hypeable language in really ways. I know how to market it now, thank goodness. But the way you market Odin is you don't market the language, you market everything else around it. It's the ecosystem you mark. And that's what we can do with Odin, actually. Because at the time of recording, there was the Primergen posted something like, why are people not using Odin to write more platform stuff to replace it, like Electron? And my view is that, well, we just haven't got a really good platform independent GUI library yet. Now, I was working on one. That was actually, honestly, that's why I was working on, but I've stopped doing it for other reasons, right? There might be one that I may actually be able to integrate into Odin already, if that comes available anytime soon, rather than using the one I was going to write. Because if that does come available, then there will be something for Odin to do that. That'd be great. But yeah. Unfortunately, guys, sorry, the guy says it nearly missed 2 hours. Yeah, I'm about to go to bed now. So, because it's nearly midnight. So, thank you all for watching. Maybe that ArcUI, that is correct. Maybe it is that. Maybe not. Who knows? I haven't got access to that yet also, but I'd love it. That was kind of, when I saw that stream on the Best Software Conference, I was like, this is doing everything I was working on, kind of thing. I was really annoyed, but it might be the perfect thing. So I'm going to get going now. I'm going to go to sleep because it is late at night and I'm tired. So thank you very much for watching. If I do another stream, it'll be random. It won't be tomorrow night for definite because it's a Friday night. I like to go out on a Friday night and do stuff. But whenever it's again, it'll be nice, right? So thank you very much, everybody. And I all hope you've had a nice time. Good night.